Imagine this. A single steel drum can hold enough fuel to power a car for hundreds of kilometers. Yet it starts life as nothing more than a thin sheet of metal. You see them everywhere, stacked in ports, rolling through factories. But most people never stop to ask how something so simple becomes so strong. Think about this. These drums survive explosions, corrosive chemicals, and brutal transport across oceans. But here's what nobody tells you. The journey from raw steel to a perfectly sealed drum is a battle against heat, pressure, and microscopic flaws. And what happens inside that factory might completely change how you see this everyday object. We're about to step inside a world where steel glows like lava and machines slam with the force of earthquakes. You'll feel the heat, hear the thunder presses, and smell the sharp metallic air. Every drum you see has passed through dozens of precise stages, each one pushing the limits of physics and engineering. And this is where it gets truly extraordinary. One tiny imperfection, smaller than a grain of sand, can cause total failure. So how do manufacturers achieve near-perfect reliability millions of times a year? Stay with me, because the answer is far more intense than you think. Everything begins deep beneath the earth, where iron ore is extracted from massive mines in Australia, Brazil, and China. Imagine machines the size of buildings tearing through rock to pull out what that contains roughly 60 to 65% iron. That raw material travels thousands of kilometers by rail and ship, sometimes covering over 10,000 kilometers before reaching a steel mill. But here's the catch. Iron alone isn't enough. Manufacturers carefully blend it with carbon, usually around 0.2% to 0.3%, to create the perfect balance of strength and flexibility. And already, the clock is ticking, because even slight contamination can ruin everything. The ore enters blast furnaces where temperatures soar past 1,500 degrees Celsius or 2,732 degrees Fahrenheit, hot enough to melt solid rock into liquid metal. You can almost hear it bubbling like a volcanic lake as impurities rise to the surface and get removed as slag. What remains is molten iron, glowing bright orange, ready to be transformed into steel. But here's what most people never think about. Each ton of steel requires around 1.5 tons of raw ore and massive energy consumption. And as environmental pressure grows, manufacturers race to reduce emissions while maintaining quality. But the real challenge begins after this. The steel is rolled into sheets just a few millimeters thick, typically between 0.8 millimeters and 1.2 millimeters for drum production. These sheets must be flawless, smooth, and consistent across every centimeter. Imagine a sheet stretching hundreds of meters, moving at speeds over 60 meters per second through rollers. Any tiny variation in thickness could weaken the final drum. And here's the twist. These sheets are often coated with protective layers to resist corrosion, especially if the drum will carry chemicals or fuel. But how do you turn a flat sheet into a perfectly sealed cylinder strong enough to survive extreme pressure? Now we enter the heart of the factory, where precision meets brute force. Steel sheets are cut into exact rectangular blanks using high-speed shear machines operating at hundreds of cuts per minute. The sound is sharp, rhythmic, almost like a heartbeat of the factory. Each piece must match exact dimensions within tolerances of less than 0.5 millimeters. And then comes the transformation. Those flat sheets are rolled into cylindrical shapes using powerful rollers applying several tons of pressure. But here's where it gets interesting. The seam where the edges meet must be welded perfectly, or the drum will fail under stress. The welding process uses electric resistance or arc welding, generating temperatures above 3,000 degrees Celsius, or 5,432 degrees Fahrenheit. You can see bright flashes as molten metal fuses the seam together in seconds. The smell of heated steel fills the air. This seam must withstand internal pressures, exceeding 100 psi without cracking. And this is where it gets truly extraordinary. Machines inspect the weld instantly using sensors that detect microscopic defects invisible to human eye. But even that isn't enough, because the drum still has no top or bottom. Next, circular steel discs are stamped out to form the drum's ends using hydraulic presses, exerting forces of up to 200 tons. The impact shakes the ground as each disc is formed in milliseconds. These ends are then attached to the cylinder using a process called seaming, where the edges are folded and compressed tightly. Imagine metal being bent and locked together, so precisely that it becomes airtight. But here's the mystery. How do they guarantee zero leaks when these drums carry dangerous liquids across continents? This is where advanced technology takes control. Automated lines use robotic arms moving with millimeter precision, handling drums at speeds of up to 1,000 units per hour. Laser scanners sweep across every surface, detecting defects as small as zero point 0.1 millimeters. AI-powered vision systems compare each drum against perfect digital models in real time. And here's the shocking part. Even with all this technology, about 2 to 5% of drums still get rejected. But why? Because the standards are brutally strict. Each drum undergoes pressure testing where air or liquid is forced inside at controlled levels, sometimes exceeding operational limits. Sensors monitor for even the smallest pressure drop. If a leak exists, the drum is instantly rejected. You can almost feel the tension as each unit gets tested. International standards like UN certification demand that drums survive drops, stacking loads, and extreme temperatures. But here's what nobody tells you. Sometimes, human workers outperform machines by detecting subtle imperfections through touch and sound alone. Finally, drums are coated with protective paint or epoxy lining to prevent corrosion. The coating process involves controlled environments where temperatures and humidity must stay perfectly balanced. You can smell the chemicals as layers are applied and baked into the surface. The final result looks simple, but underneath, it's engineered to survive years of abuse. And yet, even now, one final question remains. How many of these are made every single year? Globally, over 300 million steel drums are produced every year, forming a market worth more than $12 billion. The United States, China, Germany, India, and Brazil dominate production, accounting for nearly 70% of total output. Think about this. That's enough drums to circle the earth multiple times if placed end to end. And behind this massive industry are hundreds of thousands of workers, each contributing to a process most people never notice. Steel drums have evolved dramatically over the last 50 years. Early designs were prone to leaks and corrosion, but modern engineering has increased durability by over 40%. And here's a surprising fact. Some drums are designed to be reused up to 10 times, reducing environmental impact. Did you know that recycled steel can make up to 70% of new drum production? Or that a single drum can carry chemicals worth thousands of dollars? Or that failure rates today are less than 1 in 10,000? Looking ahead, automation and green steel production will reshape the industry. Hydrogen-based steelmaking promises to cut emissions drastically. Smart sensors may soon track every drum across its entire life cycle. Imagine a world where every drum reports its own condition in real time. But here's the real question. Will technology make these drums stronger or simply smarter? From raw or buried deep in the earth to precision-engineered containers crossing oceans, the journey of a steel drum is nothing short of extraordinary. You've seen the fire, the force, the technology, and the human skill behind every single unit. And now, the next time you see one, you won't just see a container. You'll see a story of engineering mastery. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.